Okay, so as I had mentioned in the previous video, we're going to be talking about arithmetic with complex numbers. And in this video, we're only going to deal with rectangular format. In the next video, we will talk about arithmetic using polar format. But in this one, we're only going to do rectangular format. So before we get started, we should talk about something here with complex numbers that will come up when we're actually doing some of the arithmetic. And it's what deals with something that's called the complex conjugate. And we'll actually be using this also in the course when we start talking about power in AC circuits. We'll need to know things about the complex conjugate. So it's really easy to find a complex conjugate when you're given a number in rectangular form. The complex conjugate of this which we often just denote as Z star, that's the complex conjugate, is simply just A minus JB. So in other words, you just flip the sign of the imaginary part. That gets you your complex conjugate. So let's look at just a couple really quick ones. So let's say we have Z1 is equal to 5 plus J4, and Z2 is negative 3 minus J. Then the complex conjugate of Z1 would simply just be 5 minus J4. And the complex conjugate of Z2 would simply just be negative 3 plus J. So you don't touch anything with the real part, you literally just flip the sign of the imaginary part. That gets you your complex conjugate. Now there's reasons, as I said, we're going to be interested in that. And there's other mathematical theories and reasons why you're interested in that, which we won't go over, but there's actually applications we will use that for in this course. All right. Now let's go ahead and get into arithmetic. So we're going to first start with just adding and subtracting. Complex numbers. Adding and subtracting complex numbers in rectangular format is actually really easy to do. All we're going to do is, I like to think of it as just like in algebra. You want to think of it as just, I like to think of it as combine like terms. But be careful of signs. What do I mean by be careful of signs here? Well, let's look at a couple examples here. Z1 is equal to 3 plus J10. Z2 is equal to negative 5 minus, well, actually just do a plus J2. And let's just look at then Z1 plus Z2. Now you're going to notice I'm going to constantly write these in parentheses, and you'll understand why in a second. So I have 3 plus J10 plus negative 5 plus J2. All right, now I'm just adding, and so I just combine like terms. And so I just look here, I've got 3 plus negative 5. Okay, well that's easy enough. That's just negative 2. And then I have J10 plus J2, so that's just J12. And we're done. Nothing hopefully complicated about that at all. Now, when we do subtraction, we have to just be a tiny bit careful with our signs. So if we have z1 minus z2, we would have 3 plus j10 minus negative 5 plus j2. And when I say be careful with the signs, just remembering distributive property, that negative distributes into both of these. And so sometimes it might be useful then just to write one more line down, and this would be 3 plus j10. Distributing that negative sign, I'd have minus negative 5, which would be plus 5, and then minus positive j2, which would be minus j2. And then, of course, we combine like terms again, and we get 3 plus 5, which is 8, 10 minus 2, which is 8, so I get 8 plus j8. So adding and subtracting complex numbers is actually hopefully relatively simple for you. As I said, you really think of it as just combining like terms. We just have to be careful when we're subtracting, because you want to think of a complex number. Notice how I always wrote in parentheses here in rectangular format. It's this whole thing that's the complex number. So when you apply the negative, it goes to both the negative 5 and the j2. I see a lot of people making mistakes and only applying it to the 5. So good practice is when you're substituting complex numbers into an expression to do arithmetic, just put them in parentheses to start with. Now the next one we're going to look at here is multiplying complex numbers. Which is also not as hard as you might think. Basically, the strategy behind this one is we're going to use FOIL, and when I say FOIL, we're talking about basically back in algebra when we learned how to multiply two binomials and we did the first, outer, inner, last. Use FOIL to multiply numbers out, and then simplify. So let's look at an example of this. So let's look at z1 is equal to 3 plus j2, and z2 is equal to negative 2 plus j4. And we want to find z1 times z2. So if I do z1 times z2, that is simply going to be 3 plus j2 times negative 2 plus j4. And now we just, as I said, do our FOIL. So the first would be 3 times negative 2, so that's negative 6. The outer would be 3 times j4. Now you just multiply like you normally would, so that would be plus j12. The inner is j2 times negative 2, so that's clearly minus j4. And then the last is j2 times j4. Now you have a j times a j, so you do get plus j squared 8. Now we need to simplify. And we want to remember here, we wrote this back in several videos here, j squared, remember, j squared equals negative 1. So before I even combine terms together, I'm going to rewrite this as negative 6 plus j12 minus j4, and then I have negative 1, so that would be minus 8. And now we just combine like terms. Negative 14 plus j8. Now the good news is we'll be able to use our calculators to do this, and if you don't have a calculator that can do complex numbers, I would definitely make sure to go find a calculator that can do complex numbers. And just to show you here, I'll just go to a website here real quickly. Let's just go to Amazon.com. And I even had been looking at some calculators here, but let's just even do scientific calculator complex numbers. Let's just So you might say, how do I know it's doing it? Well, here's a, it's a $12 one, and it's got 2 of them in here. What I like to do is look at the picture and then zoom in on the picture. And what you want to do is you want to look for an I somewhere. I mean, you can look at it in the description. You see, there's no I here, so this doesn't do complex numbers. So you wouldn't want to get that calculator. Now, there's a scientific programmable one here. Let's look at this one, this Casio Scientific, maybe. Supports complex number calculations right there. But then if you look at the calculator, you're going to find here on the screen, I can find it here on the screen. Go away. Find on the screen here. Well, I don't see it on the screen here, but that's fine. The key thing here, if I go back, is you want to make sure here that whatever calculator you do have, that it supports complex number calculations. Because then this calculator will be able to do all the multiplication for complex numbers, the division, and it would even probably be able to convert between rectangular and polar form here. It actually, it looks like it has it right here, rectangular, polar, right there. REC parenthesis, POL parenthesis. So, you know, that can actually be a very useful thing to have. So if you don't have a calculator that does that, and I'll just pause it, it's Casio FX300 MS. And there's plenty of other calculators that do that. If you have like a TI-84 or something like that, but you don't need to go out and buy an expensive graphing calculator just to do complex numbers. All right, so back here, multiplying, pretty straightforward. Let's look at another example of multiplication here. So we have 3 minus j3 times 1 plus j4. And now we're going to do the exact same thing as we did before. I'm going to go through this one a little bit faster. FOIL, so first 3, outside would be plus j12, inside would be minus j3, and last would be minus j squared 12. And then this would be 3 plus j12 minus j3. Now j squared is negative 1, but I already have minus j squared, so this would be plus 12. And so I'd get 15 plus j9.